Okay, so good evening, guys. Welcome back. So we will be continuing with our Docker session. So today is a Docker-Day-4 session, and the date is 8th of your March 2025, and timing is evening 8:05 p.m. IST. Okay, so guys, in our last previous session, that is a day 3 session, we had covered majorly on the generations, right? On the generations of on the generation, right? And we discussed about the generation 3 where we try to get into the containerization platform, right? So in the containerization, what we do basically, like we try to like port all our application or build all our application in the as a containerization technology or into the Docker containerization technology, right? So we get a lot of advantage over there compared to generation 2. We are getting more advantage over there because whenever you build any application into the containerization technology, those applications will become very highly portable. It means that once it is containerized, you can put it anywhere, right? You can even run that same application in your laptop also. You can even run the same application in some of the customized board, as a Raspberry Pi, or into any kind of a board where you have very minimal hardware. Still, you can able to run your container inside that Raspberry Pi or Arduino board or any kind of a ARM board. You can run it, right? And we saw the advantage also if you are getting into the Docker agent, right? It is highly portable. That is one thing. And whenever it comes to the scaling of these applications, right, in the real time environment, that is in prod, it is very easy to manage, scaling up. So that kind of advantage we are going to get in your Dockerization. Now, one important thing is that actually that we have seen that many of the complex applications, right? Usually when you try to make it run under your physical server or into the virtual server, somehow it needs a lot of memory and a lot of computing resource it requires actually. But somehow the same application, when it starts running under a container, it always runs in a very minimal requirement, like minimal CPU and with very minimal RAM memory it runs somehow. So that is what it is that I mean that whenever we are trying to build any application, so we'll all try to build that application into the contingent technology, right? And see like how it works actually. And as we discussed that in these days, that most of the applications which have been developed today is all are microservices. And the best platform to make your application available is in a contingent technology. So that's what people have started moving. Almost all companies have started working on uh, onto the Docker containers only, right? So that's what pretty much we had covered. And also we have took an example of, we took a Java applications and we try to understand like if we try to make the same application run under physical server. So we try to run in our laptop only, right? So same Java play like Spring Pet Clinic, that application, it's a Java based application. We try to run in the physical server. We also try to run the same application into the virtual machines. And finally, we saw that the same application can be ported even to your containers also, right? So these days, what happened, right? Whenever you are trying to, build and develop any application, what DevOps usually will do that, we'll always try to check like whether we can run that same application into the Docker container or not. So for that, like you need to first build an image and make that image run under your Docker actually. That's how we do it actually. And in our process of learning the Docker, right, we'll be doing all such activity. It means that we'll try to take an application and build an image out of it and then make that image run as a Docker container inside a Docker container, right? And all of us, right, we have to have that approach of converting an application which is running in some physical server or in some virtual machine, wherever it was running, we need to make it to run under the container. That should be our objective actually, right? Okay, fine, guys. So this is what we had learned something in the previous session. Now what we're going to understand today, or what are the topics we're going to cover. So let us start with something like history of Docker, like how Docker was evolved. That's what we will try to learn. We'll also try to learn about the application models actually. Application models. It means that like what are the different application models we have. Like earlier, long back, whenever we used to build an application, or most of the applications were monolithic application or monolithic applications. right? And the second is a microservices, right? There is one more is there, which we call it as a layered architecture. I might not discuss it today. This I'm going to take in tomorrow session, right? So basically, we say that these are some kind of a like application model which we found, right? And we will be trying to discuss about these models also in our in today's session. And also we will try to see the installation of the Docker installation of Docker, and introduction to Docker commands, right? So, and also like we'll also see about the internal or the architecture, high level Docker architecture, right? Today we might see in the high level how the Docker look like, but going forward in each and every session, right, we will be discussing something more in detail about more in detail about this Docker architecture a lot. So today we might see with a very high level. So going further, we will try to learn many other new things in this architecture, right? I think guys, pretty much this much, I think we'll be able to complete it by today. Let's see if time permits, I'll continue with whatever. So I'll continue even with the architecture, some more details I will give you. So this itself will take some time to make you understand. Okay. And tomorrow session, we'll be deep diving more into the layered architecture. We'll try to learn about this. What is a Docker image all about? So many things are there which we'll be learning in all our upcoming sessions. Okay. Okay, good sir. Now let us try to learn about the history of Docker, or I can just say story of Docker. So now, so how this Docker was evolved? So Docker basically, there was a company by name Cloud. Okay, it was an organization which was basically working for some PaaS products actually, right? PaaS means platform as a service. So .NET or .cloud, sorry, .cloud was an organization working on plus products. Okay, so this company, they're working on the cloud technology where they were developing some kind of a products which are related to more related to the past products actually. So once they build these past products, to test it, to verify it or to test it, basically what they have did, they have written a tool actually. They have written the same .cloud company. They had designed the tool which uh, creates a container and test these past products actually. So it means that they had already they had designed it during the development of this past products, and they to verify it or to test this past product. What they did, right? Basically, they came up with one more tool, like which they didn't name it at the very initial, but it was without any name, right? And that what the tool is to do, right? That it is to create the containers, and they like finally with the help of these containers, they is to test all these past products, right? By running those products inside this container actually. So this is what initially they were doing this .NET Cloud work the company was doing actually, right? Right. So now what happened, right? Basically, so when they're trying to do it, actually, whatever the tool which they had developed, that is a testing tool which they had developed, right? So they had designed a testing tool, I should say, as a testing tool. Whatever the testing tool which they had designed it had some interesting features actually, right? It had some interesting feature. So the dot cloud company, right? They showed some very much special attention to that testing tool itself, which they had developed it. Even though they developed for doing a testing on this past product, but instead of working on past products, they shifted their focus more onto the tool itself, which they had developed. And what they did is they started developing more and more in that tool itself. And finally, what happened, right? They came up with a new product, or the new product which they call it as a Docker actually, right? So to make the pass products work, they have created Docker, right? So if you ask me, Rajesh, is Docker is the one which actually Docker is a company which actually came up with this technology, which is nothing but contagion. Is the Docker is the one first company? No, guys, it is not the company. It is something like which they came up with a solution where with the help of that solution you can easily create the containers. This is what the Docker are doing, right? Docker company never invented the containerization. The containerization was a part of the kernel itself. So when the Linux kernel was evolved, so we know that the Linux kernel was designed by a person by name Linus Torvalds, right? He's a guy who designed this Linux kernel actually, or Linux operating system. Now, when he designed it, basically he had incorporated a lot of features into the kernel itself, right? So, like for example, the features were something like a namespace features, right? Namespaces, C groups. These were some of the very special features which it was already incorporated in the kernel itself, in the Linux kernel itself, it was incorporated. So that special feature, what it has, right? This is what the special feature was, which was used for creating a container. So the special feature, which is a namespace and C groups, right? This was the one which was there already as a part of the kernel. That by using this namespace and C groups features, somehow we will be able to manage to create a container. So the container technology was already an inbuilt feature of the Linux kernel itself, actually, right? And one more very important thing is actually that in the Linux, actually, right, we have something we call the term as a process, actually. So this term process is everywhere. You say that okay, you go to Windows operating system, you have a process, the term by name process over there, right? And when we work on Linux operating system, we have something as a process over there. Or else generally, suppose you are working in a team, right? In a working in a team, we also follow some process. So process is something like a rule or a regulation which we follow to make sure that things are aligned or things properly get executed. That's what we call it as a process, right? Similarly, you go to any industry. Suppose you go to the Toyota company where they design the car, and when they do the production, they follow a process actually to do it. Maybe they might use a process of something like there's a process by name Kaizen, Kaizen Kaizen process. It's a Japanese based process, right? From Japan, right? The process was derived Kaizen. There are many other processes are there, right? Similarly, we have sometimes agile process, right? So those processes are those are standard rules or regulation which we need to follow it actually. So same thing, what is happening is that actually that when the Linux kernel, with the help of a Linux kernel, we can create a process actually. We can create a process. Now, this process in turn will have something known as a thread actually. Thread. Inside a process, we have something as a thread actually. So with the help of a thread also, okay, so with the help of thread, we can execute any task or function, something like that. Right. So all these features like the process and the process inside a process creation a thread, and thread will take care of something like which help us to execute some function or any task, right? All these features were part of the kernel only, Linux kernel only, and all these were already in built and developed by Linus Torvalds itself. Now, why I'm saying all these things? Because guys, actually, how you create a thread, actually, there is one kernel API is there, right? By name clone. With help of a clone, you can create a new thread actually. So it means that you can have a single individual entity like that. It means that if you can create a process, you can even create a thread also. So where the thread resides inside a process. Now, all these things, whatever I'm talking so far, it leads to somewhere of creation of the container. So it means that Rajesh, is each clone, whatever we're creating the thread, is it something like a container is getting created? Yes, sir. Internally, a clone is used, right? Which is called a thread underscore clone. A thread clone is used for creating a container. So all these features, all these are part of the Linux kernel only, which help you to create the containers technology. Now, what this Docker company did, somehow they understood like the features about this Linux kernel like this, and they try to write some library on top of it, right? Whatever the library stack or the software, and with that help of that, that which they call it as a Docker engine actually. So which they call the Docker engine. It means that the Docker engine was developed by the Docker organization. And finally, what happened? This Docker engine will provide a easy way of creating, managing the containers with the help of commands. Right? So that is what it is, guys. It means that when we try to see what exactly Docker is all about, Docker is something, it's an engine actually. That is a engine, or that is about the software stack, which will make a process, which will make an easy way of creating and managing the containers. Earlier, what happened long back before the Docker organization, like Google company was there and many other companies were there, which they were also creating a container, but they used to write a huge big program, a C program they used to write to create a container. So now what happened? Creating a container itself was a complex thing, because when the Google company were developing or working on the container technology, they used to write a C program actually. That C program, when they compile and after the compilation, when they run it, right, that C program will in turn create a container, and with that help of a container, you can be able to, you can able to launch any application, that you can able to run any application inside a container. So though it was a tedious task at the time, Google and many other organizations were using this, the feature about the kernel, they were using it to create a containers. Even many of the products, what are the products which the Google is was running, right? It was actually running on many of the products of Google were running on top of the containers only. But to the real world, right, they never revealed that they were actually using containers, because container was something which was way, way long back. The Google started using from the very beginning itself, like from the 2004, 2005 onwards, they were using. And even like you know about a very big project of Kubernetes, known as a Borg project, a Borg project. Borg project, it was a very big project, was launched by Google. The whole Borg project was actually running on a Docker container. Right. So you could understand that this inception of this contention came very long back. It's not like it's a new technology. It's a very old technology. Okay. What this Docker community or the Docker community did, that they made all this process in a very simple way. And they try to create a new containers you can launch, you can manage, you can kill any kind of a container with the understanding with the help of very few commands. With only a few commands, you'll be able to manage everything efficiently. That is a kind of a power which this Docker company has bought it actually. So now, as I said, right, Dot Cloud was an organization earlier, right? And they only designed this Docker container. Later, what happened, right? This Docker Dot Cloud, right? This company itself was renamed to a company by name Docker, right? Later, Dot Cloud. So with the popularity, I can say Docker became overnight success, and Dot Cloud was renamed as Docker Inc. company. That was later it was renamed, because of course you need to change the name also, right? With the name there will be a lot of message will be there, right? Every company, right? Why they have to keep a name and the logo, which with the name and the logo it sounds what kind of work they are doing it actually, what kind of work they are doing, what the company stands for all about, right? That's what you will see that in these days many of the companies even have they change their name also. So they were using some very old name, but now they have rebranded the name and they're doing it. Why they do also? Because just want to, they just want to showcase to the clients and or the customers that, right, we like what kind of a technology which we are working and what kind of a service we can give to our end customer. That branding name has all those information. That logo has that meaning actually. That's what these people we keep. Some of the companies will be frequently changing the names, or they'll be upgrading the company names actually. Right now, fine guys. So I don't really get into much into this, because there are a lot of theoretical stuffs are there with this history and all. Okay, let's try to go some more details. Now, the basically, guys, this dot cloud was started by some group of people, and one of the co-founder of the dot cloud was a person by name Solomon Hykes. Solomon Hykes. So he is a main guy actually who designed this Docker actually. He's a main guy who designed this Docker, and he is the one who's actually released the Docker. Even today also, Solomon Hike and his team only will release the latest Docker, whatever it is coming into the market, right? So that's what, right? So if you go to the Google and if you just try to do something known as a, what is it, Docker demo Solomon Hikes. So let's see. See, this is what for the first time Solomon Hike shows how Docker to the public. This is a YouTube in the YouTube they have published this video, guys, and this is some much more informative video. You can go through it whenever you have. See, this is the first almost like 9, 10 years back this company was started. See, here you could hear the Solomon guys, and you could see that the company name is Dot Cloud. Later, it got renamed as a Docker ANC company, right? So now, what I was trying to say that actually that like he's a guy who actually majorly contributed for this Docker containers actually. Okay, okay, go back here, right? Solomon guys, and we know about the Linux torvalds and all, right? Linux torvalds you know very well, right? Right? Okay, guys. Now, what is this Docker is all about? So we have been hearing Docker, and we know that whenever we see the Docker image actually or the Docker logo, we always see this Docker logo, right? Always we see this as a Docker logo, always, right? This is what the standard image we see actually, right? So this was also the naming of the Docker was also decided by Solomon Hykes and his teammates only. They only decided to keep the name of the tool. What are the new tools which they developed, right? Which they started calling it as a Docker. So basically, if you see what exactly the meaning of Docker means, right? If you go to the Google and just say something like Docker meaning, what do you mean by Docker meaning, guys? See, a person is employed in a port of ship or in a port to load and unload the ships. Actually, you will see that many people who are working under the shipyards, right? You will get so many big containers, right? So what they do, right? They will try to load and unload the container from the ship. So those people are called as a docker, actually. So what he found that actually whatever we are designing, right, what are the software we design, so that will take care of deploying deploying an application. It could be any kind of a size of the application, right? It could be some big size, application. Or it could be a very thin, lightweight application. It could be any size of application. Yes, the Docker will allow you to deploy and make it to run. And whenever it doesn't need that application, you can actually discard that application or you can even stop or kill that application which is running in the Docker container. So somehow they got impressed with this meaning of what exact Docker. It means that he's a person who loads and unloads the Docker container or the container, right? So that's what they kept the name as this software name as a Docker only, right? And we know that actually that why the Kubernetes came into the picture because that, right? See, Kubernetes came to the picture. I'm not sure whether Kubernetes meaning there is something. Was expecting that Kubernetes something like to the actual meaning, according to the Kubernetes meaning. If I go to Kubernetes meaning in Greek, say Kubernetes meaning a Greek is something like he's a governor or he's a pilot or he's a captain of the ship. That is what the meaning of Kubernetes is all about. Now you know that. See, you know that whenever we want to load any kind of like items or something, suppose you choose a lorry, like you have a truck or the lorry, right? So truck or the lorry are something which are not that much organized, right? They don't have a proper way of handling all kind of objects or things in the lorry actually, right? Haphazardly, they will keep all the things however they need. They'll try to fit it, they'll try to keep it in Docker for the shipment activity, right? From one place to other place if they want to take, right? If you are choosing the lorry as a transport, right? What they do, right? They will don't have a very good organized way, right? Whereas if you go to the ships actually, and when you want to go and parcel some luggage or something, like for every luggage there is a separate container is there of the same size or more or less of the same size. So whatever you want to transport it, right, they will try to keep that things exactly into the same container, so without any harm of your goods or something, like it will be shipped from one location to other location. In fact, like almost everything, guys, whatever you ship today, suppose you want to send some things to US and you are using a ship as a mean of transporting, assume that they'll see your goods and everything, and according to the size and shape of your good, right, they already have a container already have a ready-made container. What they'll do now, they'll take all your things, goods, everything, and they'll try to shift into the container. It's like a box actually, and they'll nicely pack, close it, everything. And what they will do that they will come, they'll keep under some big container drum inside that, and that drum will be shipped from one place to other place actually. So now what I'm trying to say that actually when it comes to the Docker or shipping, right, the transport, for everything there is a proper container sizes that you will get it actually. You somehow you will get it from them, and your goods are without any defect, without any issues, right? Your goods will be easily will get transmitted. Now that is okay. It means that that's how the Docker is nothing but you manage a different container, different size of containers actually. Same thing. Now what happened, right? Now you nicely fit all the containers into the drum and you're kept inside drum, and you could see that a lot of drums will be there in the shipment in the ship, right? While it is sailing, right? And you will see that actually that who will be managing the whole ship, guys? He will be a captain actually. He'll be the captain of the ship actually, who will be managing the whole ship actually. So according to the Greek word, right? According to the Greek word, the person who take care of all the containers of different size and everything, taking in a single ship and making the ship to sail from one place to other place, he is called. The name is called as a Kubernetes actually. That's the reason what happened, right? When the Google started working on this Kubernetes project, actually, they had named this Kubernetes project because they thought that it acts like a captain of the ship only, which will take care of sailing, or it will take care of running, or it will take care of many of the different containers inside it actually. So that's what, guys, this naming was derived actually. Right. So Kubernetes is something like it is managing, or is a captain, or it's something like it is orchestrating. It is orchestrating the whole, like your Docker containers. It's going to manage, or it's going to it's going to orchestrate all kind of a Docker container, right? Which is happening, right? That will be taken care by your Kubernetes. Am I clear on this, sir? Right? Now, this Docker, when a Docker you create, guys, always what happened, right? The Docker is tightly integrated with your Linux kernel. This is nothing but a Linux kernel. So you have a Linux kernel. So basically what happened, right? Your Docker is tightly integrated with your Linux kernel. It means that whatever Docker want to do it actually, it cannot do it alone. Always what happened, right? It sends a request to your Linux kernel. And the Linux kernel is the one which actually does some operation, right? That's how it happens actually, right? Correct? Now what happened? Because Docker was very much tightly integrated with the Linux kernel, because it was using all the features of the Linux kernel itself. That's what I'm saying, that Docker will always be dependent upon the Linux kernel itself. And Docker cannot do everything alone. It has to pass an information to the Linux kernel whenever certain task has to get executed. And the Linux kernel is the one which actually finally executes it actually. Right. So now one of the biggest disadvantage at the time, like during the very initial stage when the Docker came into the market, right? At the time, what happened, right? Because this Docker is tightly coupled to the Linux kernel. Suppose tomorrow you are upgrading your Linux kernel. Suppose you are trying to apply some patches, or you are trying to upgrade from one version to other version. Now what happened? What are the Docker, right? With the Docker, what are the contents which are running, right? That will get stopped actually. That will get stopped. It means that while when you're trying to do any kind of an apply, when you're trying to do any kind of an operation on Linux kernel, you are upgrading the Linux kernel, or you are adding some patches and all. At the time, all the contents which are running, right, it will be stopped actually, because it has to wait until the updates completes actually. So that was one of the disadvantage at the very initial stage when the Docker was evolved, right? That it has to wait, or it has to get stopped unless until the Linux kernel patching is completed, as well as once the system will get rebooted. So once the system will get rebooted, once it comes up, then you can manually you can go and start the Docker container, right? So it means that since it was tightly coupled, any kind of an issue which happens in Linux kernel, it will affect even your Docker container which is running. Am I clear, sir? So later we will see what this disadvantage, what are the disadvantages there, right? How the Docker has overcome from that, and how they slowly shifted from the very native way into the native way of working of this Docker everything. How they moved from the native way to the latest way what they are today, and what kind of advantage they have gained over from moving from the very legacy way into the new way. All those things we'll be discussing in some time now, right? So now what happened because of this one, where the Linux kernel, because This Docker was tightly integrated to the Linux kernel. And because if there's any upgradation happen, obviously all your Docker content will get stopped. That's the reason what Docker came to, what Docker did is that actually Docker try to write their own library, or they try to write their own component, which they called it as a lib container. They call it as a lib container. So this is the special feature which they have written, right? And what they did, right, with the help of the slip container. Now today, when they added the slip container, now what is happening that this Linux kernel, right, if it goes to any kind of an update and all, right, you need not to stop your Docker container. It will keep running because who will take care of it? Now it will take care by the lib container. So all these days it was tightly integrated with the kernel now. Now what happened, right? They have shifted all those focus from the Linux kernel. Now they try to design, they have come up with something as a lib container actually. So lib container will take care of everything. You need not to really worry. So there is, with the help of a lib container, you need not to even restart your container also. You can wait it. So once you make use of this lib container, then what happened that all the problems, whatever you had earlier, that got resolved automatically with the help of this lib container. Am I clear on this, sir? So we will deep dive into this lib container later, not now, but try to understand that later. Docker designed this lib container, which will take care of all kind of issues what we had earlier, right? All those were like resolved. Most of the issues were resolved by this lib container actually, right? Now, the thing is that guys, as I said earlier, right, when the dot cloud, even the dot cloud, right, that company, when they designed this testing tool, which they later called as a Docker, right? Even they also had a very initially they had a lot of problem because even they were writing a lot of C programs to create that container actually, which later they call the Docker. So if you try to understand or if you try to go through the what do you call uh, there's an article is there which right, what happened, right, like one second, top tell what is it actually, isolating Linux kernel space, yeah, this is what it is. So one question comes, Rajesh, like suppose I want to create a Docker container or I want to create a container without any commands. So if you go to this article, I'll give the link, guys. This is a link. This is a very nice link which they have, somebody has written from Bangladesh, I think. So what he has written, right? If you come down, he's a guy actually, Mohammad Ridwan. He has written it, and this fellow has written a nice article. In this case, if you come down, he has written a C program, right? This is a C program. With the help of this C program, you can able to create your own container actually. And you could see very well that he's using some header files like this get.h, s2.h, std.h. These all C header files. And after that, you could see that he's using some clone actually. That's what I said, clone API. So clone API, what it will do that it's going to create a child process actually. And with that help of child process, he's able to, with the help of this namespaces concept, process namespace, and memory namespace and everything, right? With the help of this namespace concept, what is happening that he was able to create a container actually. So this is what the C program which you are in, and you will get the output and you will get the namespace. With the help of the namespace, you will be able to manage to run a container in that actually. So that's how, if you go to this article, you will get some good insight picture about like what are this isolation all about and what is on this namespace. So anyway, namespace and all I will discuss in some time. So this is how they started creating a UTS names actually, namespaces they write. This is the C program again. With help of this, you will be able to create a namespace actually. And in the namespace only, you will get that container concept actually. Am I clear, sir? So I would recommend you to go through this link. Some of the things you might not understand, but that is fine, okay? But if you go through it, you'll be able to understand certain concept in the namespace and all, right? You'll get to know about what a namespace is all about. And those are features about the Linux kernel only, right? Okay. Now, clear, sir? Okay, good, sir. Now, coming back here, so I think that's all about our history actually. I need not to really go in detail, but this is what somewhat we got to know. So now, one problem is that actually, guys, what happened on big problem, right? Like with the Docker, because by the concept, by the way the Docker was designed, Docker was a lightweight actually. Lightweight is something like where, like whatever the minimalist thing which it requires, only that much is required. We don't need any other thing, right? See, for example, for the application to run, right, it needs an application server, right? And also it needs some little amount of memory and some little amount of no CPU process. Only some minimal thing is required it to run that application. So what we do when we try to give this minimal things to the applications can start up and running, right? So it means that you created something as isolation area which is container, which has a very minimal information. With the help of very minimal, you are able to run an application happily without any issue. So it means that actually you try to make sure that all the unwanted things what you don't need, right? You just try to remove it. Only you focus more on what is required actually. This is what the philosophy about the Docker container also. When the Docker was designed, even a Docker NC or Solomon Hike did the same thing. They try to make it very minimalist things actually. And that's the reason what happened, right? This from last 10 to 12 years or 15 years, right? How Docker was evolved so fast because of this reasons only. But we know very well that, like whenever we try to get something more, right? Because the Docker has seen a lot of success in the last 10 years. Huge success they saw at a very beginning because they didn't knew that their product is going to work in such a big way that a lot of companies have started adopting the product or they started using the Docker into their work, right? They never thought like that at the beginning. But what happened, right? Once they, like when, no, when more and more stuff comes, when more success will come, what are the other things which will come, guys? Do you know when more success come, what will come? Chanakya Gagan, oh, when anything, suppose for example, when you get more and more money, what will happen to you? You'll get some false pride, right? False pride, thinking that I'm great. No one is there like that, right? Same thing happened even with the Docker community also. Now, what happened, right? When the Docker, their philosophy was something like a thin. When the Docker become more and more famous, now what Docker did not, Docker started adding more and more new features. They start adding more and more new features, thinking that will give more features. So as a process of that, what happened, right? They are making the Docker container more and more fatty now. So the Docker, which was very minimal, now a lot of new features are getting added day by day, day by day. Now the same Docker container, which was thin now it become very thin or it become very thick or it become very fat. So it means that they went against of their own rule, what they had set it actually. And that is what happened, that over the period of time Docker was declining. A lot of people had a lot of issue with the Docker container because it was no unrestricted. It was giving so many features was not really required, right? Whatever like with whatever the idea thought process which they started this company, right, they're slowly drifting from that actually away, and they started adding more and more features. Later, after some point of time, Docker actually realizes saying that they were wrong. Actually, they're doing it in a, or they are working in a wrong path. Actually, so they stopped it and they came back again. They started resolving all their issues. Whatever they had created, right? They started slowly resolving all those issues. This is what had happened at the after some time. Like Docker went into a large something like a lot of like disturbance happened between the Docker and the Kubernetes community or nothing but CNCF. Like, and then Docker said that, okay, we will not write all those SHIM layer and all, we'll not do it, we'll not manage it. So Kubernetes also had a fight with the Docker community. So many things happened actually, right? Later, after some time, what happened, right? Like Docker was acquired by a company by name Mirantis. So Mirantis acquired Docker company. So we know that, guys, this will keep happening in in the real world, right? Many of the companies, big companies will start eating the small companies, right? Like for example, HashiCorp company, it is acquired by the IBM company, right? Similarly, like VMware was acquired by Broadcom, right? Yeah, Broadcom company, and Harman company was overtaken by Samsung company. That will keep happening in the life. We can't stop that, right? Big companies will always try to acquire small companies, right? By giving more and more money, right? Like the Dell company, they took the EMC company like that. Even like this Mirantis, they acquired this Docker company by paying huge money for it actually, right? Even that like GitHub was acquired by the Microsoft company, right? Microsoft is the one who manages now everything about the GitHub, everything. They manage it actually. Fine. Is it fine, guys? Still here? Dino sir, any doubts you have? Gagan? Any questions so far?
No, sir. Good. Thank you.
Okay, great. Now, let us try to understand about the uh, application models actually. So we know that there is something as a monolith, and we have something as a microservices. And as I said, right, we'll also have something as a layered architecture, which we will be discussing in tomorrow's session, not today. We'll understand about what is layered architecture and whether the Docker follows this layered architecture. Yes, it follows the layered architecture. What is this layered architecture is all about? We'll try to discuss in tomorrow's session now. Okay. Now, what is this monolithic thing actually? So before we get into monolithic thing, that's what I said, guys. Like like when the Docker was adding more and more features and making it more and more fatty or thick, right? During that time, what is happening? That many of the other companies they started coming up with their own contagion technology, and one of them was what is it? One of them was a Rocket Container. So Rocket Container says that okay, whatever Docker was giving, we'll give it the very minutes thing, right? Right, RKT is a Red Hat's Rocket Container. So that's what they had come, and they were playing. They were also slowly grabbing the market, and they become a very big competitor for Docker actually, right? And see, that's what when you try to do any kind of a small mistake, right? People will be waiting for you to do some mistake so that they can enter to the market. That's how this Rocket Container, like Podman container, so many other containers came into the market at the time, and there was a huge competition between all these containers actually, right? Now you know that whenever there is a huge competition, there's a huge competition between different competitor. See what happened, right? There will be a lot of issues will happen actually, right? It is something like like where like one company will try to override his own rule or regulations onto the other company, right? Something like that. See, and also like the customer will become for the customer or for the end user, right? It becomes very difficult to choose which one to go with that. See, for example, if I want to give something an example of something like we have a mobiles, right? We have different types of mobiles we are having. Earlier, like 5, 6 years back, every mobile company they came up with their own charger. You remember they have something, they became their own charger, right? Some companies came up with something like LED charger, pin kind of a charger. Some company came with some other charger, right? Something it looks like a something like a small USB port kind of a thing, right? Where you can insert into the jack and the charging will happen. So seeing all these things, what Apple did, Apple said, okay, I'll also come up with my own charger only, with my own charger type. So all this nonsense was going on, right? Because all the new company, startup company who design and develop this mobile, right? They came with their own design of charger itself. So this was something nonsense going on in the globe actually, and a lot of big communities who are telecom based companies, right? They came forward and they said, please stop all this nonsense. So come up with one unique charging or a charging way where like all the companies should adopt actually. And now you know that we all are using 99%. We all are using C-type charger only, right? Right, because we have to maintain some standard, otherwise there'll be huge disturbance, and that disturbance will affect the end customer. Same thing happened when many of the other containers came, right? They were not managing or maintaining the standard. There was no any kind of an org who managed all these things. Haphazardly, the way they wanted, they were designing, they were giving all kind of solution end customer. This created a competitive world, no problem, but to the end customer, it gives a lot of confusion. There was no standard was maintained. So at that time only what happened, right? The Docker community, Rocket, and many of the community, they said, okay, we have to stop all these things. We all have to come up with under one umbrella, right? Where what happened, all kind of whatever we are developing, it has to meet some standard, right? It has to meet some standard. That is what the standard, what we call as an OCI, right? So what is this OCI standard is all about, we will be discussing in some time. Am I clear on this, sir? Right? So because as I said, right, when Docker became more and more pride, a false pride, when it started adding more and more features, the Docker container was becoming more and more thick, and you are compromising with your own ideology. Then if you are really going with the container which is having more and more features, which is becoming more and more fat, then why I have to go with the container? I can directly go with the virtualization technology, right? Which was earlier was given, right? So virtualization in the virtualization also you can go and you can deploy or you can run your application, right? Why we came to the Docker, or why we came to the container technology? Because container technology has more and more. advantages compared to your virtualization or even compared to the physical server where earlier you were deploying the application. Because here what happened, right? You can able to do easily you can port the application if you are making your application as a container, right, or into the contagion, you will get more and more features. So if you're compromising with that itself, what happened, right? People will tend to lose the interest to get into the container. That's what happened. The Docker at after some time they realized that they were doing mistakes. They stopped doing all such mistakes of adding more and more features. And then what is happening that they agreed to come out with some standard where we call it as an OCA standard. Right? What is OCA? What is the full form? All those things we'll discuss in some time. Right? So you might ask, Rajesh, what is this rocket and all? Sir, we'll come across with all these things later, sir. Don't worry. I will try. I have to talk about what is Podman and rocket. What is the difference between all these three contagion technology between rocket to the Docker and with the Docker with the Podman. Everything I have to discuss in some time, right? And that is very interesting. Also, we should all have to understand the differences and what are the features it provides. All such things we should know before we choose for anything, right? Now, come back here. So what I was discussing that we have three different models, right? Monolithical, microservices, and something which we call the layered architecture. Low layered architecture time being, we will not consider this. We'll see it later, right? So in case of monolithic, guys, what is monolithic? See, monolithic something, as the name says, monolithic. Mono means single, lithic means it is like a stone actually. So in the Greek word, monolithic means it's a single tire or it's a single stone. So you know that in many of the ancient time, a lot of ancient people, right, who are into different civilization, they used to construct the temple, the whole temple in a single stone. Or else they used to carve the big, like deities and all into the single stone only. For example, in Karnataka, I'm not sure how many knows about that. There is a god by name, there is a deity by name Shravana Belogola. I think you might have heard about Gomateshwara, Shravana Belogola. Right? Gomateshwara, Shravana Belogola. Shravana Belogola is a place which is from Bangalore. It is approximately, I think, some 250 miles. Right? Right. This is what it is. See, this is the god. He's a Gomateshwara. I could see that it's a single stone. So this whole deity was carved in a single stone. So it's a single tier architecture. It's a single stone. So it means that actually they took a very big stone and they carved it and they nicely came up with this deity actually. And this god actually, he is nothing but our Bahubali actually. He's a Bahubali and right, he's a Bahubali and he is in a Nirvasta, means he's not wearing any clothes actually, right? And you know that our Jainism, right? The Jain community, they follow him actually because there are two kinds of Jains are there. I think many are there, but mostly category into one is Shwetambara and Digambara, right? Digambaras are the one who don't wear any clothes at all actually, and they follow this Bahubali a lot actually, right? So this which is there in Karnataka, it is near Hassan. This is built in a single tire or a single stone actually. The same thing is actually, what do you remember monolithic means? It is actually this architecture in built into this whole application is built as a single architecture. It means that whenever anyone has developed an application, it's a very large application which has all the components in it actually. That because of monolithic, right? So now, for example, assume that, for example, I'm building an application, something like an e-commerce application. Assume that. So this is 1 second. Let me take some images. Okay, let me close all these things. Okay. Mm, right. I'll take some server. So this is server. So I have one server here, and let me have one more server here. Actually, there are two servers are there. So now what we do, guys, basically, like we'll try to develop a big application. Consider that application as an e-commerce application. Like we know, like most of us in our lifetime, we have used the e-commerce application, right? Amazon or Misho or else Flipkart, right? These are all e-commerce application where you can go and you can buy any kind of a product or anything which you want to buy, right? You can go and buy it. So that we call the e-commerce application. Assume that we are developing some big e-commerce application. This is e-commerce application. E-commerce application. E-commerce application, right? And and we know that for this e-commerce application, it's a very big application, it's a very large application. With that, all the things, all the features about this application, it is built inside a single application only. It is something like, yesterday in last session, we had run our Spring Pet Clinic application, right? The jar file, right? So that jar file was a single file. It's a large application of a single file only. It means that all the features about the application you will find in the single in the single application itself. That we call it as a, so this is what we call it is a monolithic actually. Monolithic. Monolithic actually, right? And we know that like whenever we are developing such large application, of course, like we will be having even the database also, right? Right, we also have a database also. So what we do basically, we'll take this database and we'll try to have this database up and running in your other server. Now, whenever your application, right, or for example, whenever any user want to communicate actually, so I will take a user as a Chrome browser itself, right? So whenever the user who want to access this application, so what they do, right, through a browser, what they'll do, right, they will try to connect to this e-commerce application. They'll try to send a request or they'll try to communicate to this e-commerce application. All these users actually. And in turn, what happened? This e-commerce application, it takes care of all activity, right? Say, for example, this e-commerce application, they have written something like uh, 2 million lines of code they have written actually. So the whole e-commerce application, it is written in 2 million lines of code, right? And also, obviously, when they write this code, actually, when they write this application, usually they'll try to choose some kind of a programming language. So what they'll do that they will try to either use a Java or they'll either use something like a .NET, right? Or what else they'll either use a C sharp or they either use the Python language, right? Any kind of this language can be used to develop an application, right? So what they do, they take the single application, they take the single application which is Java, and they'll try to write the whole code of the e-commerce application that is nothing but 2 million lines of code. They'll try to write in the same single language only, and almost all the features of that application. Say for example, you want to log in it actually. You want to log into the application. It means that you need some kind of a identification. You need to log in from username and the password, right? That feature is also there here actually, which we call it as an identity. Assume that identity. Okay, identity, right? After that, what is happening that you need some other features. Say, for example, like you need what are the other things, guys, which you have it? Something like Rajesh, I want to show the catalog of that application, right? I want to show the display. So you'll be having something as a catalog like this, right? Catalog. And you'll also have something as a cart. Actually, you know that whenever you are selected any product to buy, you'll push into the cart, right? Cart, right? And finally, what is happening that you need to do some kind of a payment actually. So you will be having a payment also. So it means that the whole 2 million line of code, whatever written, right? All these codes are part of all these features of that application. You want to do the payment, so you have a payment application inside the same actually. And finally, what happened, right? Suppose you want to update the inventory, you will be even having the inventory also, right? You want to do any kind of a user administration activity. Even the user administration activity is also there as part of the same e-commerce project application. So you have many of these features which are part of the same 2 million lines of code only. So all these codes are part of the same application, which is e-commerce application. Am I clear on this, sir? Right, guys? And as I said, right, all the whole code, the 2 million line of code, we will be either choosing Java language to write it, or you will be using either .NET or Python. Any one language will choose it to write it actually, right? So it means that actually all your business logic, everything is developed as a one single application. The whole logic, business logic, will be using. That is what we call it is a monolithic actually. right? And whenever the user is communicating the end with this e-commerce application, so it does the process, and finally all the information or all the data has to be saved, right? So finally your e-commerce application will try to communicate to the database, and in the database all your details or the data are stored in this database. And this all together, this whole database is not running the same server, but it will be running in a different server actually, right? Now, so what we understood now, guys, in case of a monolithic, let me write here monolithic. All the business logic is developed as single application. The whole of e-commerce is developed as single application using any one programming language, right? It could be either Java, or it could be either .NET, or it could be a Python. So you might ask, Rajesh, is it possible in case of Motigal that this identity, right, this part of the code, it can be written in Java, this part of the code best suited to use a Java, a .NET, can use a .NET for writing this, or for the payment gateway, I found that Python is very good compared to when it comes. Can we divide this whole application, when writing in different languages when it comes to monolithic? No, it is not possible. You cannot do like that way actually. You can write the whole e-commerce application with a monolithic type in the same one language only. Whether that code might be efficient for these features or not, that is immaterial. But we have to use the same language. This is what one of the disadvantage what you found in monolithic. Remember, the whole or entire component or your application component has to be written in the same language. There is no flexibility to use some other languages. Am I clear, sir? Okay, sir. Very good. Okay, and then let me write down here. All the code is developed as one large code base. So what are the advantages you will see, guys, when it comes to monolithic? What the advantage can you see? So here what happened, right? The one advantage which I see here in monolithic is that actually that it is very easy. It's very easy. It is very easy to, or it is very convenient to build and deploy, because everything is part of the same application. For me, managing will become very easy when it comes to monolithic actually. So what happened, whenever it comes to any kind of a build and deployment activity, right? There the monolithic is very simple, because you have to only build the whole application, and then like you have to take and deploy it in one time. It's a one-time activity, right? And there is nothing like a it's not like it'll create a problem while deploying and all. It'll be smoothly, it'll go and deploy it actually, if you're following a proper way actually. So managing, maintaining the builds and deploying everything is very convenient and easy when it is monolithic actually. So here advantage what I found is that actually that it is very convenient to build and deploy. Okay. What's the disadvantages? The disadvantage that actually that, suppose for example tomorrow you said, okay, fine, Rajesh, all these features are good. Like assume that this e-commerce application is a Misho application, right? And this identity is one of the part of the code actually. As a part of the whole application. Now assume that a user wants some new features, right? Say for example, whenever you want to create a user account in that app, in that e-commerce app. We know that actually we go to the Misho.com or Amazon.in. We go and first we will try to create our accounts, right? By giving our email ID. Once you give an account and all, what happened, right? You can able to log into the application with the help of our email ID, right? Now you know that whenever I try to log in, always right, you have to give user and password. But there is some feature is there, sometimes remember me. You know that? There's a remember, there will be a button where you remember it. If you click on it, for the next time when you try to log in it will not ask you any user and password at all. It will try to maintain all your details in the cache, right? It maintains the cache. So it means that that is a new feature, right? So assume that a developer got to know that, okay, there is some issue with the identity part of code of your of your e-commerce. Let me add that feature, something like remember me. So he will try to add that feature. He might write some 10 or 20 line of code to add that features. Once you add the feature, what happened, guys? You have to, what happened? You have to rebuild the whole application again. So when you do a build of the whole application, and when you try to come up with the newer version of the application, and whenever you want to deploy that application, you have to make your whole application down during deployment. So there will be a downtime of your entire application, because you are doing changes to this only identity part of the code. But as part of this, what happened? You are building this whole application. So time will take for you to go and compile, deploy it, and everything. So you will see some kind of a downtime which is going on whenever you are trying to build a new application and build and deploy it. Actually, this is one greater disadvantages in Montical. So what is the Montical? So even smaller changes also requires downtime of the application, right? All of the application should be in the same programming language, right? As I said, right, it should always be in the same programming language. You cannot have a different languages actually, like that. Correct, sir? Now, again, one more big problem, what you see in the real time. So this is your e-commerce application, fine. Today is okay, right? So suddenly, when you're trying to come up with something, a big app day where you are, like where we are giving huge discounts for your end customers. Say, for example, in India, we have a, during Diwali or during Ganesha Chaturthi or during New Year, right? All this e-commerce portal, right? They give so much offers actually. Like something like a big app day, right? Where they give a lot of discounts or lot of coupons and all. So now what will happen, guys? Like usually what happen, your customer base will increase and a lot of traffic will come in actually, right? So in that case, whatever the server you have, right? So that server which is having a very limited hardware, let's say for example, it is having something like a uh, 16 GB of RAM memory and with four virtual CPU or four core CPU. If it is not able to handle this whole the traffic, right? The huge traffic which is coming in on the big app day or big day. So then what is happening, that you need to scale, right? You need to scale, or you need to increase the instance of your server actually. You need to increase it actually like this. You have to increase it like this. You have to increase it actually. Right? So that's all. It means that you need to take care of all this, I think, everything. It means that you need to go and manually increase the instances and make sure that even this same e-commerce application runs in all other servers also. The same replica of the same application has to run. So it's a tedious task actually. It's a tedious task. When it comes to vertical, all these things problem, right? It leads to a lot of issue in the real-time production moment, and it's very difficult to manage and maintain. You need to monitor constantly. Like if there is any kind of traffic spike happens, then what happens? You have to go and or manually or automatically, whatever way, you have to increase the number of instances, and then like whenever there's a load is less, you need to decrease it actually. So these are very manual steps which you need to take care of it, and it is very difficult to manage when the application is designed as a monolithic actually. Am I clear on, sir? And one more thing, as I said, right? Like for example, one of the very disadvantage of the monolithic, what happened? See, as I said, right? Suppose for example, if there is something like you're doing a big app day where most of the customers are using your application, and suddenly an architect comes and he said, "Oh, okay, man, no, there is some problem with the inventory, man. It is not properly updating inventory." Do you think that during that time, the developers, or during that time or one day before, the developer can fix all the issue, do a compilation of the whole application, then again try to deploy it? It will take more time, right? Or during the real time, when the customers are already accessing, they started accessing or using that application. During that time, you say that no, sir, there is some problem with the inventory, and let me try to quickly fix it, and let me try to rebuild that application, and then try to deploy the application. You cannot do like that when there is a when there's a real-time transition going on. You cannot stop that application. If you stop that application, you lose the customer lose all the connections, and perhaps even they lose all kind of operations, whatever they're doing. Right, there'll be huge loss. it will impact your whole business. You cannot do all those operations at all. So it means that the monthical, what happened, right? If you have monthical, if you want to really do any kind of a changes at the nth moment, it is very difficult to do it actually. You cannot do it. You have to leave as it is. Even though if there is any bug or error in their application, still you have to release that application with the same error or the bug into the production environment. This is one major big disadvantage actually. Guys, do you agree with me all these things? Chanakya, did you understood whatever I said so far?
Yes, sir.
There are a lot of disadvantages are there in monthical, right? There's no question about it. It's there actually. That's the reason what happened. Most of these disadvantages that happen, it is being easily resolved in the microservices actually. That's what why we went into other model, application model, because all this disadvantage, whatever you are seeing in monthical, it has been easily resolved in the microservices. Right? Now, so let us talk about what is microservices, right? Right? Microservices. Now, what we say in the microservices, basically, we say that whatever the features which are having or whatever the component of this entire application, right? Say, for example, your whole e-commerce application, okay, which has many components. If you see, it has many models, like for example, identity model, catalog model, cart model, payment model, administration model, or inventory, whatever the models are there, right? Right? All these models, what happened, right? What they do, right? They will, in microservices, they'll try to write as a separate service or the separate application they'll try to do. So what they'll do, right? Basically, they will try to. So if this is the microkernel architecture, right? So what they do basically, they will take the small piece of code of your monthical application, which is we call identity service. This identity service. Assume that. Okay, they break down the application into a single service. They call the identity service, which means that they try to develop a separate identity service of that, and whatever it does an operation. For example, whatever it does, it'll try to have its separate own database actually. Okay, it has its own database like this, a small database, right? And here what is happening that your identity service, it will be storing all the changes, everything, or all the things, what are the data into its own database like this. Same thing what they do, right? For every component of the same e-commerce application, they will divide to different services like that, or different application altogether like this actually. Like this. And so this is something like catalog. This is something like a cart, payment gateway, inventory, and administration. Okay, so in case of microservices, what they do that they will divide the whole application, what are the applications there, as a single services or single application or function, right? And for each and every single application, it maintains its own database. Okay, you might say that Rajesh, why don't we have a single database, and this in single database, all this application can write and do an operation, read and write, or it can save all the details into the same database. It can do that way also, but that will become more and more complex actually, right? So in that case, what happened, right? You will just you will not be using this one. Instead, what happened that every service or every application had its own database actually. This database can be your Postgres, it can be a Redis actually, it can be MongoDB, it could be any database. So it had its own database. This is a design architecture of your microservices, right? Now, what is an advantage which you have found here? Say for example, when you are running your whole when you are making your application, e-commerce application, when you are announcing something like a big app day, you'll be announcing saying that, okay, you can get the pen drive for 1 rupee, right? Or a huge discounts are there in many products. So a lot of customer base will increase, right? During the big app day, or during the Black Friday, or during the Thanksgiving Day in US, right? You could see that this e-commerce application, shopping application will, the traffic will be very huge. A lot of people will be trying to make use of that application. So in that case, if you come over into the microkernel, if you see which is the application inside it, or which is the service or function which will be most busy always, you will see that the most busy will be cart and the most busy will be payment. What about the other inventory and administration identity? It will not be that much loaded, right? Right? It means that it will not be that much loaded, but whereas some of the service will be very highly loaded actually. It means that more and more requests are coming into this service only. For example, card service, right? There will be more and more requests are coming. Similarly for the payment, because more and more customers are doing online payment. So this payment application, right? It will be having more and more traffic into it actually. So in that case, what happened, guys? You know that Rajesh, during the big app day, right? My catalog or else my cart, right? This will be more and more what? It will be more and more load. Let me try to do a scaling of this only. So what they do, right? In microkernel, in microservices, they'll try to scale like this actually. More and more based on the load actually. Same thing for the cart also. They will try to scale it actually. Scale. So in this case, what happened that you don't need scaling for identity service, or you don't need a scaling of admission. This is not required. But while the scaling of these services or application, right, it is required, right? So that's what this can be easily managed actually. I'm saying it actually. And whenever it doesn't need it, actually, what happened, right? You can scale out actually. You can scale out. Scale in and scale out is very, very easy to manage when it comes to microservices. Since what happened, right? And one more advantage, what you will see in a microservice, that actually that because you are writing all this, the whole application code, you are divided into different services or different application, smaller application, which you are writing it. It becomes very easy to choose the language which you want. Say, for example, if you choose an identity service, okay, I have to use the Java only. You use the Java. For the catalog, okay, I need Python is very good when it comes to catalog, right? And when it comes to the cart, .NET is very good actually. You can choose your language actually. And in microservices, all this application, right, they can communicate each other over each other with the help of a HTTP protocol. They'll communicate each other. Whenever they want to communicate each other, it's very easy to communicate each other with the help of HTTP, actually. So earlier it was HTTP. Like later now what happened that you can even communicate the gRPC. Okay. gRPC means Google's remote procedure call, we say RPC, remote procedure call. So either use HTTP or gRPC to communicate each other. Whenever each service want to communicate each other, they can use either HTTP or gRPC, right? There are many other methods are there to communicate. They can communicate each other. It becomes very simple. So if you're having a different languages designed for all these different various application, with the HTTP one, with the HTTP, you can able to communicate each other. It does that. HTTP or gRPC, there's no barrier for the language, guys. It is immutable, whether it's a Python, it's a Java, it's a .NET, it is immutable for it. It has to only transfer the data actually. It has to only communicate between two services. Then HTTP protocol or gRPC is used for the communication. So that's the reason what happened, right? It has become very easy to manage. Say, as for example, tomorrow you have written the whole payment application designed in a .NET, right? You have designed it. Assume that actually what happened, right? You got to know, okay, there is a language by name Go language, and Go is having more and more features compared to the .NET. So now what you think about it? Okay, Rajesh, can I replace the whole payment gateway or the payment application into the Go language? Yes, sir, you can go and replace it. So replacing these features or this application into some other language is very, very easy when it comes to microservices. Because a monolithical, as I said, right, you cannot do that way. Monolithical doesn't support it. You cannot have a different language for different part of the code of the same application. It's not possible. Or if you want to try to do it also, it is very difficult to do communication between this part of the code to this part of the code if you are trying to use different language. So in monolithical, that is not at all allowed. You have to use only one language itself for designing the whole thing. Am I clear on this, sir? Correct, sir? So same thing here also, like we'll have the same thing. Like for example, we have the same users actually. Here also in micro, right? We'll have a users, right? So what they do that they will try to communicate to your identity service. First, they have to log in, right? So this user or the application, right? They try to first communicate. First, they have to do authentication, right? So the request will go to the identity service. Through that, authentication authorization happen, and they'll try to log into that application. After log into the application, they'll go with the catalog, try to view all the products, and finally they'll add the product to the cart. And after that, actually, you have to do some kind of a payment, updating the inventory, and doing all kind of user admission activity of your entire account, right? That can be managed. So you have these different services of the same application. So that's how we design in this microkernel. Am I clear on this, sir? I hope that you understood, you got some point. Right? You take any microkernel or any microservices architecture, every microservices will have its own, has its own database. It could be, as I said, it could be Postgres or MySQL or Redis. It could be anything. It has its own database actually. Right? So let us see, guys. Let us try to write some notes on microservices. So in microservices, what is it? Each business component, or I can say functionality, is created as individually runnable service. Each service can be scaled, and each service can be individually updated. Individually updated without impacting other services. So what it means, the same thing like here in case of a microservices, if suppose you want to add any new feature into the identity services, you're only doing this part of the code only. You're not touching catalog or cart. So whatever the catalog cart which was executing, which was running, right, it will be as it is. You'll only be concentrating to do some changes here in identity. Once you do the changes, once you do it, you can again go and do a deployment, and you can bring back this identity service back actually. So it is very easy to update, manage, and deploy everything in microservices when it comes to, whereas the same thing in Montical, it is very difficult actually. Right? Okay, come back here. Advantages. So why we are learning all these things? Because that we have to understand, guys, what is Montical, what is microservice, and what is layered architecture when it comes to Docker, right? Because now all these things, Docker, with the help of a Docker has simplified all these things now. So Docker is one level high compared to what we're discussing. So all the problem statement, whatever we have seen so far, right? In some models, right, there's advantage there, there's a disadvantage there. In some other models, the same thing. I will not say, okay, microkernel are the best. No. In some situation, montical are better than microkernels. In some other situation, microkernels, microservices are better than montical. So the debate will be keep there. You cannot say that which is good, which is bad. Every model or everything has its own advantage and disadvantage. You have to go with that only. But what I would say that now at this present generation, where a lot of applications are being designed and developed, they tend to always go with the micro. They will try to they'll try to develop as a microservice one, because they know that at the end of the day, my application somehow it has to run in a cloud platform that is onto the container only. That's how these things are going on. Otherwise, you will see that many other companies are the older companies, still they're following Motical only. They have their application which is running as a Motical kernel only, a large big application. And with that itself, they're getting advantage actually. If they tend to go the microservices, they might not get that kind of advantage. That's what some companies they never go with the microservice at all. Right? Say for example, your medical healthcare, right? Or else many of the banking application which were running under the mainframes, right? Still they are using that huge applications. Bank, they want to do, they don't want to really disturb that. Yeah, slowly when the technology is progressing, when more and more requirements are getting progress and more new features customers are asking, at that time what happened, all these companies they tend to they tend to go with or tend to go migrating from montical to micro. They'll do that actually, no doubt in that, because whatever the feature they want, maybe montical might not give all the features in a, over a period of time. After that, what happened? All these companies who are using or working on Motical, they have to slowly shift to the microservices. right? So, I was just saying one example I had quoted earlier, right? See, the what is it? That X application, right? Or you are nothing but the whole Twitter application. The Twitter application, complete Twitter app was written by uh, in the microservice itself, actually. Later, what happened, right? When the Elon Musk came and when they try to understand the whole process of how these microservices work and everything, what is an architecture and all, they tend to realize that actually they are going to get more and more efficient if they are converting the whole application from microservice to montical. And what this X did, right, which is now Twitter, the whole application was redeveloped again back to the montical architecture as a montical, and they try to port it, and now they are getting more and more, I can say, they're getting more and more features. They're getting the way the application is working is the speed is very high compared to microservice, and they're getting more and more advantage when they got into the vertical. So now what you will say, the company which was all these years were using microservices, if they are going to the vertical, which we call the very old traditional deployment model or old traditional application model, what you can say, right? See, it's something like which they identified it actually. It's not like that simply on a something on a air they took a decision. No, they had did a lot of verification, and they did some kind of a simulation, and then finally they arrived with that conclusion saying that no, now we have to now shift our application from microservice to the vertical. So that is a big decision which was taken, and which Elon Musk said as yes. He said yes. And some of the team people, they developed this whole application as a vertical, and they try to port it and everything. They try to even compare with the microservices with the vertical, with the help of, with respect to speedness, with respect to the health, with respect to the application, how it behaves, right? They found vertical is more advantage, right? So it could happen anything else. It's all depend upon the design, or it's all depend upon how they take it, and like what is their end requirement, and what they want to achieve through that application, right? All depends upon all those factors actually, right? I cannot say that only microservice is the best service which all have to use. Not like that, right? But yet it is one of these best, and we have seen so many advantages over with the microservices. We have seen that actually, and we have to, I mean, we have to agree with that actually. You cannot say no, right? You have to agree it actually, right? So, what is an advantage you are finding out in case of microservices? Deploying without downtime. This is one major thing which we in Motical, this feature is not there. Frequent updates you can do, because as you are individually managing all this application, right? Right, managing everything will become very easy. It is a technology independent. You need to really stick into one technology. As I said, right, you can design and develop all the services into different languages. Independent. What's the disadvantages? The disadvantage is that actually it's very complex. It's complex actually. No doubt, it's a complex architecture, and it needs I can say it needs or I can say it needs an external orchestration, right? That is one of the disadvantage actually, right? So it needs an external orchestration is something, like there has to be someone who have to orchestrate in a proper way, guys. So for example, Kubernetes is a very good orchestration tool, right? Uh, it's a platform where it can orchestrate any kind of an application in a proper way. There has to be some kind of a very good orchestration who manage it actually, right? See, for example, like for example, if you go to the mini music concert, I think some of you might have gone it. If you go to any music concert, it's a music, can say music orchestration. Okay, have you gone to this music concert? Okay, now what do you see, guys? These are the different instruments played by the different people, right? Expert, but there will be a person actually who will be managing the whole music. Actually, he will take a stick and he will be exactly saying it. If suppose some player he does some mistake, this person will realize it actually. He knows that actually the way he's playing, right, it is not correct at that instance actually. Then I don't know, for with some signal he will say to this player saying today, and he will say that you play in a very proper rhythm way, like that he will say in a stick, so that this person realize, and then he'll try to correct it actually. It's the same thing like that actually. When we are having so many applications which are running, so many different applications, like for example in the microservices, the same application, big application, you're doing to small different function or application, right? Small application. Somebody has to be there to manage this application to work in an effective way. So you need some kind of an orchestration mechanism to do that actually. And the best orchestration mechanism is Kubernetes only. Kubernetes one who manage all this application and who say that, okay, which application is actually properly working, which is not working, what kind of a repair or anything is required for that application if it is not properly working. That is something you are managing, or you're doing an orchestration actually. Am I clear on this, sir? Right? And if you want to see, if you want to give an example of one of the example of how it is managed well, right? So I Google, right? What has done, right? Google has developed an application which is something like a eShop application. So eShop completely they made it to they designed in a microservice itself. So eShop on container. If you try to just check this one. So eShop, I think I have to go to the GitHub. Okay. And where is it, guys? I think I have to go to this link. Yeah. Let's see. Yeah, this is what the architecture is. So this is eShop reference application. Now, if you open this in a new link, see here, guys, can you see eShop? So they've designed what they've done, the whole application they break into different services. See, identity services, catalog services, order services, basket services. See, and for everything they're having their APIs actually. The APIs actually. And that APIs in turn what happen, it communicates through its own database actually. That's what I said, right? For every application or service, it needs its own database. And here what happened after this is something was identity, catalog, order, and basket service, and something like a payment service, right? And here you have something admin service, right? You are having something event bus actually. And here something, these are the clients. It could be in browser or the mobile. So what they do, right? They either send the request through the mobile API or through your browser with the browser API, right? And this from here, what happened? The connection will go established to this application. So this is some very good example of how the microservices looks like actually. Am I clear on this, sir? Right? Okay, guys. So, guys, I think we can stop it now at this point of time. Take a half an hour break, right? And we'll soon get back at 10 o'clock. I mean, in my timing, right? 10 p.m. IST. Is it fine? So I'll stop this recording, and we will have one more session. I will take one more hour. I will take it, and then like we will try to get into something we call it as a Docker actually. Right? What is Docker is all about, right? And we'll also discuss about something about what is a lib container. We'll try to discuss about that. What is the Docker architecture? We have to learn about that also. And then like many other things are there which we need to discuss now in the Docker. Is it fine, guys? So shall we get back? Shall we again meet at 10 o'clock? Dino sir, Dan, everyone, Gagan, Maya sir?
Yes, sir. I'm okay.
Okay, guys, thank you. So, guys, as I said, right, we have to give more and more time now, right? Because we'll be learning a lot of things now, and we need to get into deep dive into Docker now. And Docker is a very big topic. It's not small topic at all. It's a very big topic. We all have to give maximum time now, actually, right? So that's the reason I would urge that we need to spend more and more time. Let us give more time so that we'll finish off this learning. Whenever when we meet in the weekend, right? You give more and more time, we'll finish stuff. Rajesh, take more time and finish stuff. And then we finish your business, and then we'll go to recording also later if you want it. You can go to recording also, or you must go to the recording also. So that, and when we are, I'm saying, guys, always go with the 1.5 speed, 5x. If you are getting bored or something, go into more and more speed and try to cover the video as fast as possible. Right? Okay, guys, with that, I will stop it and we will meet again. We will try to rejoin the same link, right? So let me stop it. Let me stop the recording.